Today let us learn few more terminologies of graph theory. First one is walk. A walk is defined as finite alternating sequence of vertices and edges. Finite alternating sequence of vertices and edges, beginning and ending with the vertices, such that each edge is incident with the vertices preceding it and following it, and no edge appears more than once. If you look at the definition, you may feel it is complicated, but it is very easy. If I take this as my graph, few definitions are quite easy when you go through the examples. Okay, this is my graph. Let me name the vertices. Vertex 1, 2, 3, 4, 5. Name the edges as A, B, C, D, E, F, G and H. Okay. Now this is my graph. It has got 5 vertices and these are my edges. Now walk is nothing but simply alternating sequence of vertices and edges. Is there any condition? The condition is walk always should start from a vertex and it should end with the vertex itself. Need not be the same vertex, can be any other vertex. That is one condition. And another condition is no edge should appear more than once. Okay, let me define first walk. Say I'll take, for this example I'm taking walk 1, I'm calling W1. Okay, first one starts with the vertex 1, then edge C, vertex 3, then edge E, then vertex 4, then edge G and ends with the vertex 5. Let me write. First it always should start with the vertex, so vertex 1, then edge C, then vertex 3, then edge E, then vertex 4 and edge G, then vertex 5. So this is a walk. Walk is an finite alternating sequence of finite. Always remember it's a finite, or not like I'll start with here. Here it's a finite graph, so no problem. It's a connected graph. So walk means it's always alternating sequence of vertices and edges, beginning and ending with the vertices, such that each edge is incident with the vertices preceding it and following it, and no edge appears more than once. See here, I have started first condition. It's alternating sequence of vertices and edges. Of course, since I'm starting here, vertex, edge, vertex, edge, vertex, edge and vertex. So it starts alternating sequence of vertex, edge, vertex, edge, vertex, edge, and always it should start with the vertex and it should end with the vertex, and each edge in the walk should have the vertex preceding it and following it. Of course it is having now. So vertex 1 and edge C, when you consider, it is having vertex preceding it as 1 and vertex following it as 3. So this condition is true. And one more thing, no edge should appear more than once. Here edges are C, E and G. None of the edges are repeated. So this is a walk. Walk is a finite sequence of vertices and edges beginning with and ending with vertices such that each edge is incident with the vertices preceding and following it, where no edge appears more than once. Okay, this is one walk. Let me define few more for this example. Walk 2, that I'll start with the vertex 1, edge A, vertex 2, edge B, vertex 3, edge C, and I'll come to vertex 1 itself. 1, A, 2, B, 3, C, and 1. I'm coming back. This is also a walk. One more, W3, I'll start with vertex 1, A, 2, B, I'll take up 3, C, then again I'll come to 1, and then I'll take vertex D, and I'll take edge D and vertex 4. 1, A, 2, B, 3, C. I'm coming back to 1 and I'm continuing by taking an edge D, and I'll end up here at 4. And one more. I'll start with 1, take up vertex 2, edge A, vertex 2, edge B, 3, C, I'll come back to 1, I'll take up D, then 4, then I'll take up edge E, vertex 3, take up edge F, then I'll take up vertex 5, edge G, vertex 4, edge H, and I'll come back to vertex 1. Okay, this is one more. I'm starting with 1, A, 2, B, 3, C, 1, D, 4. Then I'll take up E, 3, F, 5, G, 4, H, 1. I'm taking like this. Okay, no edges repeated now. Okay, now I'll take up one more. See, these are all walks. And now I'm defining, say, let me take this. This is, you have to check whether it is a walk or not. Okay, start with the vertex 1, edge A, vertex 2, edge B, vertex 3, edge C, vertex 1, edge A, and vertex 2. Now I'll start with vertex 1, A, 2, B, 3, C, 1, and again I'm taking edge A and coming back to vertex 2. So now this is not a walk. Why? Because I'm repeating edge A twice. I'm taking this route twice, so that should not be the case. Walk is alternating sequence of vertices and edges which begins with the vertex and ends with the vertex, and each edge is preceding and each edge is incident with the vertices preceding and following it, where no edge appears more than once. But in this case, edge 2 is repeated twice, therefore W5 is not a walk. Remember one thing, vertex may appear more than once in a walk. Vertex may appear more than once, like this, may appear more than once, but edge should not be repeated. So a walk is also called as an edge trail. An edge trail or simply a trail. I repeat the definition of walk. Walk is a finite alternating sequence of vertices and edges which starts and ends with the vertices such that each edge is incident with the vertices preceding and following it, where no edge appears more than once. Next is closed walk. Closed walk. See, if I start from this vertex and I'm taking an edge A going towards vertex 2, I'll take edge B, vertex 3 and C, then I'm coming back over here. Okay, this is also a walk. A walk which starts and ends at the same vertex, then that is called closed walk. A walk which starts and ends at the same vertex, then it is closed walk. Here in my example, I can look at the walk 2. Here I am starting at vertex 1 and I am ending up here at 1 only. So walk 2 is an example for a closed walk. Then even W4, walk 4, I am starting at vertex 1 and I am coming back to vertex 1 itself. Therefore, this is one more example for a closed walk. Next is open walk, which is not a closed walk. Open walk is not a closed walk. A walk which is not closed is called an open walk, and an open walk in which no vertex appears more than once, then it is called path. These are the important definitions. One is walk and another one is path. It's a walk, in fact, it's an open walk, but in which no vertex appears more than once. It's open walk and the vertex should not be repeated. Path is an open walk in which no vertex appears more than once. In fact, in my example, I can consider this W1 as a path because it's a walk, of course, and it is open because no vertexes appeared more than once. Therefore, I can take W1 as an example for path. Length of a path means how many edges are there in that walk, in that open walk. That gives me length of a path. If I consider this example only W1 here, length of this walk, path is 1, 2, 3. How many edges are there? 3 edges are there. Therefore, length of path means number of edges in the path. Length means number of edges. Here, length of path means number of edges in a path. So if I ask path length of if W1 is a path of length 3. Observe one thing here in the graph. If I take walk 1, it starts with 1, C, 3, E, 4, G, 5. You can observe one thing. Here end vertices are of degree 1 and rest is of degree 2. This if you consider irrespective of path only, 1 for this vertex degree 1, and for this vertex one edge is C and another edge is E, so degree is 2, and for this vertex one edge is E and another edge is G, therefore this has got degree 2, and this is the end vertex, only one edge G is incident on that respective of walk. Okay, with reference to this walk, end vertices are of degree 1 and the remaining vertices in the walk are of degree 2. So when you consider a path, the terminal vertices are of degree 1 and the remaining vertices in a path are of degree 2. Terminal vertices are of degree 1 and rest are of degree 2, in path, okay, which is a subgraph of a graph in fact. So it's a subgraph and here terminal vertices are of degree 1 and rest vertices are of degree 2. Next is cycle or circuit or a closed path or circular path. Okay, it's a closed walk. It's a closed walk in fact, in which no vertex appears more than once other than the initial vertex. Means cycle is a closed walk in which no vertex other than the initial vertex appears more than once. Means it starts and ends with the same vertex, so only the initial vertex is repeated twice and none other the vertex are repeated. For example, in this graph, if I consider walk 2, only the vertex 1 is repeated. Of course it is a closed walk, and only the initial vertex is repeated. Okay, so this is the example for cycle or circuit or circular path. And even here, in walk 4, we feel like it's a closed walk, so we may think that it is a cycle, but it is not a cycle because of course vertex 1, the initial vertex is repeated more than once, but the thing is along with the initial vertex, vertex 3 is also repeated, so W4 is not a circuit or a closed cycle, closed path, circular path or a circuit. Next is connectedness of a graph. I have already mentioned what is connected graph and disconnected graph in my earlier class. On the basis of walk, we are defining connectedness. Connected graph. A graph G is said to be connected if there exists at least one path between every pair of vertices. Graph G is said to be connected if there is at least one path, if there exists at least one path between every pair of vertices, between every pair of vertices. Otherwise, graph is said to be disconnected. Suppose, see, this is connected graph. Okay, this is connected graph. If I draw this graph, these are the vertices and this is an edge, then this is disconnected graph. One more if I consider. So this, let me call it as graph 1, graph 2 and this is graph 3. Okay, these two are disconnected graphs. These two are disconnected graphs because I should to say that graph is connected, every pair of vertex, between every pair of vertex I should have at least one path. When I consider here this vertex and this vertex, there is no path between them. Therefore these two are disconnected graph. And see, when I consider a disconnected graph, I can take this connected part and this one isolated vertex, this isolated vertex. They are nothing but the components of disconnected graph. Means connected subgraphs of a disconnected graph are nothing but component. So when I consider this part as a component, if only this part or only this part, they are nothing but the components of a disconnected graph. Connected subgraph of disconnected graph are nothing but component.